This question asks us to find and draw the total displacement vector of a ladybug that starts at 8, 2 and ends at 3, 6. First, let's find the coordinates of the starting point of the ladybug. I'll start at the origin and I want to go over 8 and then up 2. So over 8 units, up 2, and this is going to be the start of the motion. Now the ladybug ends at 3, 6, so let's go over 3 units, then up 6 units, taking us to here, and this is the end. Okay, to draw the displacement vector, we start here with a tail of an arrow on her initial point, and then draw an arrowhead pointing toward where she ends up. Now we can give that some symbols, and we don't want to call it just delta x anymore, or just delta y. Delta x was reserved for a horizontal displacement. Delta y was reserved for a vertical displacement. This is actually going to be a combination of both horizontal and vertical displacement at once. So we want to give this vector the label delta r. And I want to put an arrow over its head to show that it's a two-dimensional displacement vector. Now one thing we can additionally do here is we can show the delta x and the delta y that creates this displacement. By that I mean the ladybug moves to the left here 5 units. And from there she could go up 4 units and arrive at the same ending point that she would have got if she just went diagonally there. And we can label those things. This one will be delta x, and this one's delta y. Now if we want, we can put arrows over their heads just to make it clear that they are vectors in a two-dimensional plane, and that's fine. And what's cool about this is we can actually show how delta x plus delta y results in delta r. It's called vector addition. Now that's not the only way that we can get to that ending point. We could take this path instead. We could go up 4 units, and then from there we could go left 5 units and still arrive at the same spot. So we have delta y here and delta x. Now you should be aware of one other way of writing this, and that would be instead of delta x, we could actually call this delta r with a little subscript x. And that means the same thing as delta x here. So just be aware that you might see it written this way sometimes. But both of these things mean the same thing. Delta rx is the same thing as delta x. And delta ry is the same thing as delta y. So just be aware you may see these interchangeably used. Now we want to actually put some numbers to delta x and delta y though. So let's see how long delta x is. If we count the units, it's 1, 2, 3, 4, 5 units. And delta y is 1, 2, 3, 4 units. We would actually get the same result if we counted the delta y units here. And this points directly up, just like that vector does. They're actually the same vector. It doesn't really matter where it's located. Over here, we're going to the left 5 units, same as we have down there. So how do we write delta x? There's two methods that we want to be aware of. One of them is vector form, and that would be by taking a number and attaching it to an I or a j. For x, we use I, but for y, we use j. So that's just one way to write what delta x and delta y are. Notice that we could plug those right in here, and instead of having delta x plus delta y equals delta r, we could put negative 5I plus 4j equals delta r. Would be one way to write it. So delta r can be written as negative 5I plus 4j, or we can write delta r in component form using the angled brackets here, negative 5 comma 4, and these both mean the same thing. Okay. Now how else could I express the delta x in component form? Like what would that look like? It would look like this. You have to have two components, but this delta x only points in the horizontal direction. So when it comes to his vertical direction, it'll just be a 0. But he points to the left 5 units, so we'll have negative 5 comma 0. And that is one way to write this. Now let's try delta y. We'll have two components because it's a vector. And we're going up, so we're not going to the right or left. We'll put a 0 here. We're going to go up 1, 2, 3, 4 units, so 0 comma 4.